if you have a smaller p-value, that means you have stronger support of the alternative. You have stronger evidence against the null hypothesis. Small p-values mean a lot of evidence. Again, going back to this null distribution up here, if you have this null distribution, if your sample statistic were, say, right here, that seems kind of like evidence against the null. It's sort of out in the tail. There are not too many dots like yours or more extreme. However, if your p-hat were further out in the tail, say out here, there's even fewer dots like yours or more extreme. This would be a very small p-value. In my little drawing, it looks like there's only one dot out of the total that are like my sample statistic or more extreme. That's a tiny p-value. So the smaller my p-value gets, the further my statistic is out in the tail, the further it is away from the null hypothesized value of pi. So the further your statistic is away from the null hypothesis value of the parameter, the smaller your p-value. That's a very, very important concept in the class. Smaller p-values is more evidence against the null. Smaller p-values is more support of the alternative hypothesis. Bigger p-values is the null hypothesis being plausible. Again, back to the null distribution picture. I have this little null distribution here. If my sample statistic were, for example, right here, and I were counting samples that are like my sample and more extreme, I'd be counting all these dots. That's a lot of dots. That would be a big p-value. There's lots of samples that are like mine and more extreme. So that is saying, it seems like the null hypothesis may be plausible. Look how close my sample statistic is to the hypothesized value of pi. Seems like that pi hypothesis could be plausible. Big p-value means our null hypothesis is plausible. Small p-value means we have a lot of evidence against the null hypothesis, a lot of support for the alternative hypothesis.